Let's get started. I hope you can see the screen. If you can't, well, let me fix something. Okay, I think you guys can see now. So let's go over the problems now. Problem 7. Write the equation for the graph shown below after it is reflected over y equals negative x. Alright, what do we do? Well, notice that this is negative 2 comma 4, and this is 5, and that's a 5. What do we do with this? Well, it goes to the origin. That's something we know. And it also goes to a point negative 2 comma 4. So we all know that the equation of a line is ax plus by equals c. This is the normal equation for the line. Now, if we put in x equals negative 2 and y equals 4, we should expect as we should expect it to be equal to c. We also know that it's 0. So let's just use point slope form. I mean the normal mx plus b, slope plus slope intercept form. Now if we go left 2 of that way and up 4. That's equal to a total slope of negative 2. Because going that way, going to the left is a negative 2. And the 4 is 4 down every single time. Or you can say 4 down and 2 to the right, which gives you 4 down to the right is equal to negative 2 as the answer for the slope. The slope is negative 2x plus, goes to 0, so the origin is just 0. Just meaning that the y-intercept is 0, and y equals negative 2x. Putting them all into one side is 2x plus y equals 0 or c. Alright? Now let's guys have a try on the question, problem 8. Let's guys have a try on this, and tell me answers to each other. Okay, let's get started with the question. So the answer is not D, or someone who was spamming in the chat D. It should be A. Now remember what we did to confront these problems before. Y equals negative x. What does this mean? Well, it means the x coordinate is either the inverse of the y coordinate, is equal to the negative of the y coordinate, or the y coordinate or and same thing. Let's just let the and the y coordinate is the negative of the x coordinate, meaning that 5 comma y equals negative x. So if we have the following coordinates 5 comma negative 1, it becomes, after reflecting it over y equals negative x, it becomes negative 5 or negative 1 and positive 1 comma negative 5. And adding them up gives you negative 4. Let's move on to problem 9. Let's go over trying this question and probably message me through chat. Well, I think I give you enough time. I think you should be able to solve it. And let's get started. So, what is a key insight to this problem? Well, a key insight to this problem is that notice that we just graph it. Let's just graph. That's the only insight, or not have, but we might have other insights later. So A is negative 2 comma 1. Okay, negative 2 comma 1 over here, A. B is the A reflected over Y equals 3. We can just think about it as Y equals 3. 1 has a distance from 3, Y positive 2. So this is 1, and this is Y equals 3. It's below it. So it also should go up. So it should now then be negative 2 comma 5. Now, the point C is the B reflected over the Y line Y equals 3, X plus 3. This tells you that from negative 2 comma 5, we want to show that we want Y to become X plus 3 and X equal to Y minus 3. Just rearrangement. As you can see, that's pretty easy. It's just X becomes negative 5, Y is equal to 8. Point D is this image of C reflected in the line Y equals, X equals 0. Over here, it becomes negative 5 comma negative 8. Now, what's the distance between A and D? We're just taking the inverse of 8. So we just have distance between negative 2 comma 1 and negative 5 comma negative 8. That's the distance is total of 3. That one's the distance of 9. But this doesn't seem to be a correct answer. Let's redo. It's okay to make mistakes. We can learn from it. So we know that by 1 D, so for point X comma Y, we get, let's just graph it. Oh, hold on. To make stuff more accurate, we'll just graph it. And it's really good to graph it to give you a visual interpretation of the problem. Alright, here we are. And let's just graph this. Alright, so we know that 1, we know that the original was negative 2 comma 1. And what was the other one? We knew that point B is image of A reflected over the line Y equals 3. So what is Y equals 3? It's this line right here, right? We reflect it, we get to negative 2 comma 5. That's the new point. Now, point C is the image of B reflected over Y equals X plus 3. We graph Y equals X plus 3. And we can see this is exactly on the line. And we're reflecting negative 2 comma 5. So this should be around over here in 2. Let me see. It goes down 4, and we also go right 4. Should also go down 4 and go right 4. So from 0 comma 3 should become negative 4. Wait, no, it should become. No, this is not 4. Oh shoot, it's 2. So it should be 2. And then we're also going to go down to 1, and then we're going to also go down right 2, or 1 comma 2. As we get Y equals X plus 3, yeah. And then 5 is equal Y minus 3 is X, so it's just 5 minus 3, it's 2. Alright, so after that, we get, next thing is just reflecting D, point D off C in the line X equals 0. What is the distance between A and D? So D is reflected over Y X equals 0, right? And reflect this, it just gives you negative 1 comma 2. Right? And that leads you back to the original point. As we can see, we got from 1 comma 2 back to negative 1 comma 2. The distance, as we can see, is basically square root of 2. Here is just 1 and a 1. We know that's square root of 2. So the answer should be square root of 2 if I'm incorrect somehow. Or if I'm calculating incorrectly. Oh, my fault. It's because this one and it has to go over here. So it has to, I calculated this kind of incorrectly. Sorry. It's 2 comma 1. And then it's just reflecting, get negative 1. Instead, not negative 1 comma negative 2, we get negative 2 comma 1. So then this ends up to be 0. But this is why we make sure to double check our calculations mistake, as I did just right now. I did a calculation mistake. So it's really great to do a checkup on your solution and make sure in competitions that you actually got the right answer, not making some random mistakes like I did right now. All right? Good. So let's move on to the next question. So the answer is D. Now, we're going to be talking about geometric object transformation. We already went over this part, and we also went over before in the last lesson. So let's do this. Which of the 5 T-like shapes would be symmetric to the one shown with respect to the dashed line? I'll let you guys have a try on this question. Tell me your answers to chat. What's your question?
I cannot see.
Can you see now? Let's get this started. So we're reflecting over the horizontal line over here. I'm in the vertical line. So we're just reflecting. So the square should be the innermost, as you can see over here. And that's gonna be our answer. See, it's the only thing we need to know. Or you just see the angle you want to just visualize that. Can I rotate it? Yeah, basically. It's a 90-degree rotation for it. Almost, but like not exactly. Just for the T, that's a 90-degree rotation. Alright. Let's move on to problem 10. I think you guys can handle it. As you guys have a try this question and tell me answers to chat. let's get started. So basically, how I'm supposed to do this is notice that it's 2, 7 reflected over x plus 2y equals 6. Or, so to speak, is negative 1/2 of x plus 3. So y is equal to negative 1/2 x plus 3, right? So the y coordinate is basically 2, because after we're plugging in 2, we get the answer. Now, the x is different. It's just y minus 3 times 2, negative 2. So you get 7 minus 3 is 4 or negative 8. Or am I doing this incorrectly? Let's see. Alright, so we know that 2, 7. So if y equals 7, so we know it was negative 1/2 x plus 3. Plug in 2 for x gives us negative 2 for the y. So y is 2. Or am I doing something wrong? Yeah, I don't think y is equal to 2. Let's use the experiment. Let's just use the graphing as we did before. Alright. So we have x plus 2y equals 6. Using a graphing calculator is not technically cheating because we can graph it, but I'm not kind of lazy in order to graphing because it's gonna take a lot of space. So I'm just gonna use a graphing calculator just to help you visualize the graphing. So x plus 2y equals 6, and we also know that there's the points are 2, 7. Notice that we want to see how much it goes down and to the left right now. It goes 2 to the left and 4 down. So it should also go 4 down and 2 to the left, or negative 2, 1. And there you have it. This is the visualizing part, which I think most intuitively the easiest possible move. Basically, the easiest possible way of solving it. And I'm going to use this way because we can see that it should be on a line with negative 2, negative 1. And negative 2, 7 should be on a line that should be perpendicular to this line or negative 1/2 x plus 3. What? Because a perpendicular is a reflection. It bisects, right? Let's move on to the next question. So the answer is B. Let's move on to problem 11. Unless you guys ever tried this question and tell me answers through chat. Well, let's get started with this question. It's really simple. It's just rotating it by 240 degrees clockwise. Clockwise is going this way, going to the right, to the left, circling around, rotating. So this is one. Let's split it into 120-degree sectors. 120 degrees is 1/3 of the way. So 240 degrees, 440 degrees is 2/3 of the way. So we're going to be rotating 2/3. So the circle will be swapped with the square, and then the circle will be swapped to the triangle. So the total is going to be swapped to the triangle. So the circle should be on the triangle. And the circle, and in front of the circle to the right is the triangle. So it's going to be this and this square. Oh, hold on. I'm so sorry. I mean, the to the right is the square, and this is the triangle. And this means this answer C. Alright, let's move on to problem 12. Let's take a try this question and tell me answers in the chat. It's pretty simple. Alright, so let's get started with this question. So it might be kind of confusing, but it's a rotation of a figure in the plane of the figure. So it has to be not reflected. So it has to go through like this method. It doesn't matter which way you go. So you're gonna still get the same rotation. So let's just go clockwise. So it'll be like this for the over here, be like this over here. It's my imagination. Like this over here. You get that overall point of the shape. It's like this. Finally, like the slanted like that. As you can see, D doesn't work. C seems to work as it is in the same angle and it looks like the same as originally planned. B does not work. We don't see a B over there. And then A seems to work. It seems like to be over here somewhere. So it's A and C, not A or C. All right. Let's move on to problem 13. Let's go to try this question and tell me the answer to chat. Let's get started. So basically, what's the answer? It's 180, not 360. That's not the minimum amount. It's 180. Whoever said one, we're taking it in degrees, not an entire rotation, all right? So let's see. If we rotate this pound all the way to there, it's gonna be the same. That's a total of 180 degrees. It's symmetric. Over rotationally symmetric at 180 degrees. You guys think about it, it's similar to a rectangle. It's really a rectangle itself, actually. Just like a rectangle. This is the center. Rotate it. We will still get the same object after 180 degrees. So the minimum is 180 degrees. No more, no less. right? So I reached the end of the class period. I hope you guys have a wonderful night, and I'll see you next session. Bye.